Trip Zero here, and I've got a load of fun. What this is a 14 cell in parallel pack of 18 650 batteries. On top, we've got a TC4056A charger, LiPo charger with over current, over voltage, under current, not undercurrent, under voltage protection, and that's connected to our battery via these wires that I've soldered on underneath this little plastic here, straight to the metal. And we've got a current meter hooked up for that for some experiments, and then it's going to a boost converter that boosts 2.6 volts, as low as 2.6 volts, all the way up to 5 volts USB at 2 amps. Now I've got a whole bunch of devices to test this. What's the purpose of this guy? Well, I am in the process of writing some code to automate the smart things in my house, and I have some smart plugs that we use in part to charge our devices, phones or batteries, both wirelessly and in a connected manner. And I'm putting in rules so that it only charges from AC, or that outlet only turns on when there is solar power from my solar panels. But that may only be for 3 or 4 hours a day, depending on how many devices are using the solar power. I've got it. All the smart devices will register themselves with the what I call the device manager, and it will keep track of how many, the load that is on the solar power system, and it will kick off devices, for example the charger, if there isn't enough solar to power it. So this is kind of a way to make more use of solar power. But anyway, so to get around the problem of I can only charge things during the day, and sometimes I need to charge my phone at night because that's when I get home from work and my wife gets home. So I need a way of charging a battery or something during the day so that I can charge my phone and other devices at nighttime. So this is what this is. That's its function. So we're going to do some tests and both see if we can achieve the 2 amp output that these guys are rated at, 2 amps each port, and the circuit protection on this is 3 amps per unit, and then we'll see just how fast this charges as well. So let's start hooking up some things. First thing I've got hooked up, and by the way, I've just got these stuck on with double-sided sticky tape, and this guy doesn't want to stick too well, but that's okay. We can put him wherever we want. And right now it is hooked up to the wireless charging pad that will theoretically draw 2 amps. This is a not completely charged but not completely empty Moto Mod battery, wirelessly charging. So let's check out. I'm going to put it on right now, and we should see some action. Alright. Oh wow. So immediately that red light comes on, and I can hear a high-pitched hum, some noise. That's 1.4 amps. That is curious. So right now he's having a hard time. But it is charging. Should see a light. Yes, that is the I am charging light. He has got an I am charging light, and it just shut off. Wow. That's not very cool. I'm trying the other port, and same story. Wow, this is not good at all. How noisy that is. And then it shuts off. That's terrible. Wow. Alright, we're trying a battery now, and it is charging at 1.2 without a problem. So that's very interesting how this guy can't, this wireless charging pad, which is rated at 2 amps input, cannot, causes some stress on this system. Now I did notice, look how many amps is going out. So over 2 amps is going out to this guy, who can only support 3. So I'm curious, if we plug back in our charging pad and we measure at the here, if we're getting over 3 amps and hitting our current limit. No, we're not. And in fact, oh, but if I, that is so funny. Placement is everything, wow. And it just turned off. Very interesting. So I have to unplug this and plug it back in to get this guy to turn back on. Alright, let's try that again. This time we will monitor this as we put the charger on. Got the noise. That's a really high pitched. That's so funny. Wow, that's quite the, well, maybe this is not quite the device to do to charge. The battery seems alright. The last thing I want to do is actually charge this, the battery pack itself. So we've got our little adapter hooked up. Now this is a 2 amp adapter. We should be able to charge at 2 amps because these two devices are in parallel with each other. There we go. The red light means charging. And since this is fully charged, just about fully charged, I don't expect it to charge very much. I should discharge this a little bit more to try and charge that. So it actually charges. A little bit on the output. I don't like that much. That is, okay, so that's DC. So it's charging about 200 milliamps, which is about similar to what that's reporting, 325, 220. I expect this to be less accurate because it's using the Hall effect sensor. I guess that's it. So one thing I do have on the way is a 3 volt to up to 12 or 24 volt adapter, and I'm going to use that with the USB-C charger. In fact, I could probably test out my USB-C charger with directly connected to this, because I think it's got a boost converter in it, if you saw my last video. So maybe I will do an experiment with that in another video. Until then, this has been an interesting experiment. I hope that if you replicate this, this will give you some tips on what to do, components to use, whatnot. Have a good one. Cheers. Trip Zero out.